Hi, everyone. Thanks for joining us for the next episode of Model Mondays. My name's Anna. I'm an event planner for Reactor, joining you from Redmond, Washington. Before we start, I do have some quick housekeeping. Please take a moment to read our code of conduct. We seek to provide a respectful environment for both our audience and presenters. While we absolutely encourage engagement in the chat, we ask that you please be mindful of your commentary, remain professional and on topic. Keep an eye on that chat. We'll be dropping helpful links and checking for questions for our presenters and hosts to answer live. Our session is being recorded and will be available to view on demand right here on the Microsoft Reactor channel. With that, I'd love to turn it over to our host for today. Thanks for joining.
Thanks, Anna. Well, welcome everyone. We're at episode 5 of series 2 of Model Mondays. I'm Lee Stott, I'm the host for today, and today we're going to be talking about fine-tuning and distillation, and we actually have Dave Luto from the product team who have been working with the OpenAI models around fine-tuning and distillation. So I'm going to just quickly introduce Dave and let him come on and just say hi. So Dave, welcome to the show.
Thanks for having me, Lee.
Excellent. Great to be here. We're going to be talking about a really interesting area of fine-tuning and distillation. We're specifically going to be focusing on the OpenAI models today, aren't we, Dave? So can you just give us a bit of a background to yourself? What do you do within the product team?
Sure. So I'm part of the general Azure AI Foundry team, which is quite large these days. But I focus primarily on model customization. So that includes everything from fine-tuning and distilling models, primarily on the OpenAI side, but slowly starting to focus on other models as well.
Excellent. So for the viewers watching today, is this like super advanced, or can anybody get started with fine-tuning and distillation?
That's a good question. So if you're already using models for inference today, this should be pretty approachable. It might introduce some new features and tools of AI Foundry, specifically evaluations that you might not be familiar with, that even if you choose not to go down the distillation route, might be valuable for your general agent or application development.
Cool. So we've got a great demo set up for everybody. So again, huge thank you, Dave. I'm going to bring Shamila onto the stage, and she's going to give us a quick update around all the different activities that happen with models this week. So as you all know, Models Mondays is something that we put together each week, isn't it, Shamila? You know, we're here from June through to September. We're live every Monday as part of the YouTube channel, and every Friday we have our AMA, so Ask Me Anything, which happens within our Azure AI Foundry Discord group. So please, if you're interested in joining these, we've got all the resources at aka.ms/Model Mondays. So Shamila, anything exciting happen this week?
Every week there is something exciting happening. And yes, we did have, I mean, for us, every week there are new models launching, but just even outside of model world, we have agents and tools news. So there's no dearth of information. And of course, our goal in the weekly highlights is to share the top 5 highlights for you, make sure you all know what's happening, and get some quick takeaways from each of those highlights. So without too much ado, just let's get into the highlights and go from there.
Sounds great. So again, please, everybody, if you do like this part of the show, please let us know. Let us know what your favorite section is. So let's have a look at this week's highlights.
Thank you, Lee, and welcome back to the weekly highlights on Model Mondays. And for anyone new to the series, in this section of the Model Mondays, we usually cover like the top 5 highlights that could be around model, that could be around tools and agents, all happening within Azure AI Foundry. And in most cases, most of these are closely tied to our model ecosystem as well. And for every highlight, you will have a QR code, take a screenshot of it, and that'll usually take you to like a learn more page, like a blog or a GitHub repo, or even to the model card in the product. So let's get started. First on our weekly highlight is our deep research in Azure AI Foundry Agent Service. And Microsoft is actually unlocking a new frontier in enterprise scale research with this deep research, which is available in public preview in Azure AI Foundry. And this isn't just another tool, it's a fully programmable API and SDK powered service that allows you as a developer to build agents that are capable of web scale planning, synthesis, and analysis. And powered by OpenAI's advanced research capabilities and grounded with Bing Search, deep research enables developers to automate complex research tasks with auditable, source traceable outputs integrated directly into the enterprise workflows. So whether you're building agents that summarize like medical literature or analyze policy trends or performing market scans across the open web, deep research is built for programmable transparency, multi-step orchestration, and enterprise-grade governance, all within Azure AI Foundry Agent Service. Okay, now moving on to the next highlight, meet FIFO Mini Flash, the newest member of the Microsoft Phi family and our most nimble reasoning model yet. We've been seeing a lot of news around reasoning models and especially the larger ones. The best thing about this particular update is that 5.4, the mini, it's having on the small language side, we are having reasoning capabilities. It's small, 1.8 billion parameters, it's fast, and it's optimized for chain of thought and multi-step problem solving. Now, despite its size, it holds its own against models 5 to 10x larger in benchmarks like GSM 8K and math. And it's very ideal for use cases that demand fast, reliable answers for on devices or in apps or embedded in agents, and especially for edge devices where compute, latency, and memory are highly constrained. And now this is a gap in most of these model updates, reasoning model updates that we have seen in the past. And as Microsoft, we are trying to solve for that gap by bringing reasoning capabilities to small language models as well. Now, moving on to something around agents. Of course, every week we have to give a highlight, give something in the highlight section about agents because agents has become the topic today. Today we're going to talk about Agentic Retrieval, and RAG just got an upgrade with this. Agentic Retrieval brings autonomous retrieval planning to our Azure AI search. So instead of relying on a single static query, agents can now plan multi-step retrieval strategies, refining queries, interpreting results, and adapting based on task context. So this is going to be great for like legal, research, and enterprise search where accuracy and nuance will be very, very critical and will matter. Moving on, something a little different from agents and models. This is more around the database side. So developers are building LLM agents at scale, and now they can use Azure Cosmos DB as a persistent vector-aware thread storage in Azure AI Foundry. Plus, you can bring your own thread store support, and it opens the door for custom infra setups. So think ultra low latency, globally distributed memory for your agents. This is foundational for agent memory personalization and continuity across sessions. So, and finally, this is not kind of a try something new highlight. This is more of an update on an upcoming webinar that Microsoft is collaborating with Cohere and DraftWise, a customer of both Microsoft and Cohere, who are using Azure AI Foundry for legal contracting with AI. Now, this is going to be a very interesting webinar. This is happening on July 17th at 11:30 a.m. Eastern or 8:30 a.m. PST. Please log in. I have the QR code will take you to the registration link. Log in and get informed about hear directly from a customer who's been using both Microsoft and Cohere to build their AI-powered legal contracting application. And that wraps up our Model Mondays highlights for this week. And I will hand it over back to Lee. Thank you.
Hi, Shamila. So yeah, thank you for, lots and lots of new things. Somebody's already posted in the channel here. Anybody tried Grok 4 yet? So Grok 4 is now available. might be in next week's update.
Yeah, we are working on it to bring it to Foundry, but yeah, we still there are still things that needs to happen in terms of like evaluations and all that on our end. So yeah, wait and watch for the news. We will bring it here first on the weekly highlights.
Excellent. So again, in terms of like things people should be looking at, Model Mondays is all about, the types of models that are available, all the different variants of models. Is there anything like, specifically from your team that you're like really excited about in terms of these new models that are coming along?
So a few things that which we are excited about is like our model router. I know models, there are going to be a lot of models. So our team is relentlessly working on making model router, expand it to more models. And I think that will help solve a lot of the problem that you have in terms of model choice, which model to pick. Right now, of course, model router has like a couple of models, especially like the OpenAI models. But once the scope expands, I think that will be a good tool or good model to use for some of these developers who are still figuring out which is the right model to use and all that. And then we are also excited about other parts of our AI Foundry, like where we have things like around observability, and especially in the agentic world, observability will become really important. So we have lots of things going on, and of course the next few weeks to months are going to be inundated with more and more interesting news.
Yeah, definitely. So Model Router, for those who don't know, we will be covering this on Model Mondays, and we've got lots of discussions happening in the Discord around this. Model Router is really an LLM. So you just specify Model Router as that model, and then Model Router will actually decide which model to pass that inference into. So it's currently based on OpenAI and the GPT models. So if you give a prompt, Model Router will then say, oh yeah, this is an O4 mini question, or this is an image 1 question. And it will handle those model passing for you, which is really cool from two perspectives. Number one, it saves you around 60% of cost, because some prompts might be very, very simplistic, and a very simplistic answer can come back. So again, you're using a very cheap, very fast model. Again, you might want to use high scale, high volume image models. And also what's really cool about it is it allows for that deprecation of models. As a developer, you don't need to think about, oh my gosh, GPT 3.5 is going to be deprecated at the end of this month. Do I need to change my code base? Model Router will just handle this automatically. So again, it's something great to look at. And again, if we make Model Router available for more of the model families, then we can start having that greater variety in how people want to service models. So please have a look at Model Router. Very, very cool. So huge thank you, Shamila, for coming on this week. Great updates as always. Really looking forward to next week.
Yep. Thank you, Lee.
So let's move into this week's spotlight, which is all around fine tuning. So we'll bring Dave back on. So hi again, Dave.
Hello.
Again, key things around looking at model routing and fine tuning distillation. Where should people start? Number one, should people start with fine tuning or distillation, or what's some of the ground rules for doing this?
So the way I look at it is distillation, it kind of encompasses fine tuning. So it doesn't matter where you start. What's kind of important is to identify the use case that you're trying to fine tune for. Sort of like a garbage in, garbage out problem, where if you can't clearly identify the problem you're trying to solve by fine tuning, you're going to have some very poor results come out the other end. To kind of put it simply, you want to find a task that you're either struggling to achieve with a base model through prompt engineering, or a optimization you'd like to perform. And that will guide your hand as to choosing the right path with fine tuning and distillation.
Yeah, excellent. And again, it's always like that funnel, isn't it? Start at the top with prompt engineering. It's very cheap, very easy to do. Then move to the RAG and the CAG, to add data into your model. Then the fine tuning, and then the distillation. The only real considerations as a developer you should make as well is that if you do fine tune or distill a model, that model is at a point of time. It's like, you've fine tuned it and distilled it today, so it doesn't know about tomorrow. So that's something people need to think about when they do that fine tuning process. There is some really interesting nuances around fine tuning within Azure. And I know when we go into the demo, you're going to focus on fine tuning with the Azure AI Foundry SDK and with the portal, etc. what are some like the ground rules around fine tuning and distillation? There's lots of licensing considerations people need to make. So what are some of the ground rules people should be aware of?
Yeah, there's general caveats around the model providers. So typically model providers don't want people to distill the intelligence from their model into their competitors' models. It's just how the ecosystem is. So even the open models, they're open in the sense that there's usually a license that allows you to use them, like those from Meta, like Llama, for instance. But they might dictate what you can or can't do with those outputs. So if you're already using a model from a particular ecosystem, like OpenAI, staying within that ecosystem is usually easy, and it's a green light activity. There are some unique features within Microsoft Azure that we can call out, such as you're allowed to distill from OpenAI models into things like Phi. So as long as you're using them within the Azure ecosystem. So you get more flexibility with us in AI Foundry than you would if you were just working with model providers directly.
Yeah, and again, those licensing considerations are part of the model cards. So when people are looking at model cards and they click fine tune, it will say these are the requirements or frameworks that you're allowed to utilize. One of the other interesting things around the OpenAI distillation and fine tuning is that, as you said, a unique USP of Azure is the ability to do this within Azure, but you cannot take it from Azure and host it locally, can you?
Typically not. The important thing, though, is understanding the methodology and the process. So if you have a use case that is powered maybe by the OpenAI models today, the skills you develop in fine-tuning and doing distillation with OpenAI can be translated to other models. So you'll be able to take those best practices and possibly even some of your code and adapt that to cases where maybe you want to do this offline, maybe you want to use like a Foundry local environment and you want to run something on device. Your challenges are going to be less with adapting your fine-tuning capabilities and more the fact that now you're probably looking at much smaller models and really limited capabilities there anyway. Because
that's
what you can do on device today is going to always be different than what you can do in the cloud. I mean, there's a reason.
I was just going to say, size of the model, going from 100, 200 billion parameters to a 13 billion parameter model, huge difference in sizes, and again, cost.
Exactly.
So just my final question before we go into the demo is like, what are the sort of the ballpark figures? When people say, I want to fine tune a model, what are some like the ballpark figures for doing fine tuning?
So it comes down to the size of the models that you're working with primarily. That tends to dictate the size of the training bill, if you will. A lot of training jobs are billed in terms of tokens consumed. So the more complex the job, the larger the model, the larger the bill. But we're talking like, it could be tens of dollars to do some fine tuning of a small OpenAI model with an AI Foundry, to hundreds or thousands of dollars if you're doing some more complex things like reinforcement fine tuning and using a larger model like O4 Mini.
Great, excellent. So let's get into the demo then.
Sounds good.
Hello, everybody. I'm Dave Voutila. I'm a principal product manager here within AI Foundry, and I work primarily on our model customization offerings. Today, we're going to be talking about fine-tuning and distillation. But first, what is fine-tuning? So fine-tuning is all about adapting a model's behavior to better suit a task. So common usages involve domain or language adaptation, trying to make a model work better in a medical or legal context, for example, or even doing things like style and tone adaptation. Sometimes you even use fine-tuning to improve things like tool calling or instruction following, or teaching or reinforcing particular skills. So things around like classification or summarization. There's like a spectrum of NLP use cases that fine-tuning is best fit for improving versus something like RAG or prompt engineering. But fine-tuning isn't necessarily an either or thing. You could use fine-tuning as well as these approaches to really meet your objective. And if that's fine-tuning, what is model distillation, you might be wondering. So distillation is effectively a kind of umbrella term about taking a larger general purpose teacher model and using it to improve a student model for a particular task. So fine-tuning is sort of an aspect of distillation, but not always the case. We're not going to get into all the different types of distillation out there. We're going to be looking at this general flow today, where it's all about a teacher and data generation using the teacher's output to teach the student. We'll be using fine-tuning for that training part in the middle, and then evaluating and making sure that the student model actually has been improved. But why should you care about distillation? So sort of like fine-tuning, it's all about improving performance and cost as well as improving accuracy and quality. So there's numerous reasons why you might be looking at fine-tuning. Typically, they're going to be very similar to distillation. In short, it's all about finding the smallest possible model to fit your use case and making sure it still performs as well as a larger model. General rule of thumb is smaller model, it's cheaper, more performance. The caveat is, what are you trading off from downgrading from a larger model, and how do you prevent any reduction in quality? Distillation can help you with that. So we're going to look at an example end to end. So we've got some slideware, and we've also got a notebook you can take a look at. In our use case, we're going to be distilling tone. So we're going to take a very trivial use case that everyone should be able to wrap their heads around, hopefully, fingers crossed. We're going to use a prompt that's very trivial. Clippy is a factual chatbot that is also sarcastic. If you've read our OpenAI docs online, you might have seen this prompt used in some of our fine-tuning walkthroughs and how-tos. But the key here is we're going to use a simple prompt, and we're going to avoid prompt engineering. So we're going to try to solve this problem with just distillation to kind of prove a point. So the flow we're going to take involves data synthesis and using model graders. So we're going to walk through this end to end. Everything from generating the initial questions and responses and baselining our models to finding a way to build the training set, teaching our new student model how to be better at its job, and then proving that we actually made a difference in that student's life. So if you want to take a look at the code examples, if you're the type of person that doesn't want to stare at slides for a little bit, you can jump over to this GitHub repo. It's all Python in a single notebook using the OpenAI SDK and Azure Cognitive Services SDK. And then there's some AI Foundry resources as well. So the cool thing is this takes advantage of our newest offerings we unveiled at Build this past May, things like global training and developer tier. So these allow you to actually use this notebook in whatever Azure region you're in, because now we support 20 plus regions for doing fine tuning and model evaluation. So let's take a look at this workflow. So really, I've broken this down to kind of 3 phases. The first phase is that benchmarking and teacher selection. So the key here is that grader here in the middle. So we're going to use our sample prompts, and we're going to generate a bunch of responses from all our various models we want to kind of measure the quality of, and we're going to use this grader to score and rank them. But what is a grader? First we need inputs. We're going to take these inputs from, we're just going to, in this case I generated these with 4.0, and then we're going to pass these through a model that is prompted with our Clippy prompt, and then output will be, its sarcastic attempt at answering the question. But the grader's job is to take all of that, so both the input and then that model's output, analyze it and produce a score. So this grader itself needs its own prompt. Here we're going to be using O3, and since it's a reasoning model, it's pretty good at just being given a descriptive task. You don't have to get very detailed. You treat it as an expert. So in this case, we're going to just say, we're going to give you something, question and answer pair, and you need to both validate that the answer is correct, factually correct, and I want you to judge the tone on a scale from 1 to 10, with 10 being the most sarcastic thing you've ever seen or heard, and 1 being no sarcasm detected. That's it. So we're basically prompting the reasoning model to say, look at this thing and output a quantitative measurement, some sort of score, and give us your reasoning along the way. So it's going to spit out some JSON. The cool thing is we're the ones designing the grader, so we get to put the pass-fail thresholds wherever we want. So in this case, we're doing 1 to 10 for the scoring. We could set it at 4. We could set it at 6. It's really up to us. And you can test this just directly in Chat Playground. You can take this prompt, hand it to a reasoning model like O3, and then give it an input. So in this case, I'm giving it a question-answer pair like we're going to be doing in the eval. And we can see what the output would be in this case. So we can see okay, question was, who wrote the Odyssey? The answer that the Clippy chatbot gave us was, just some poet named Homer, nothing special really. So is that really sarcastic? According to O3 and its directive here, it's a 6 out of 10, if it was an Olympic judge. And then also it's checking the validity. Is Homer correct? In this case it is, so the result for that is 1. Resulting score is 6, because we asked it to multiply them together. Now when you use the evaluations framework within Azure OpenAI, you can run this eval across multiple models simultaneously with multiple inputs. So you don't have to do this all manually or write a bunch of code. We can generate our input data, in this case all those question-answer pairs, all the questions. We then have the evals framework do the generation. So for each model we want to test, everything from, in this case, 4.0 mini to O3, it will pass those inputs through those models with our Clippy prompt, generate those responses, and then hand those to the grader to be scored. So now in the end, we get a nice pretty rainbow of colors, and we can see that 03 has some nice green, and in this case 4.1 nano is bright red. And if we take a look at plotting this on a bar chart, like in the notebook, 03 clearly comes out ahead, with 4.1 nano being really bottom of the barrel bad. So this is just using, just that straight Clippy prompt with no prompt engineering, and just looking at the natural ability of each model. And it's kind of more interesting when you drill into the score distribution. Not only is 4.1 nano bad, but it scores really low quite consistently, with most of their scores being 1s or 2s, where with 03 it actually put some decent ones up there, like 7s, 8s, and 9s. So we've got our teacher selected. We're going to choose 03 in this case because it's just the most capable out of the box for our use case. And 4.1 nano being the smallest model available, which also looks like it has the most room to grow. It's what I would consider within educational reach, to put it nicely. So now we need to take our teacher model, some sample inputs, and generate some responses that we will use to build our training set. The cool thing is we've really already done 2/3 of this already in the previous steps, but this is what the flow looks like. You take the teacher model, run some sample inputs through it, generate responses. The important thing is to put a grader in the middle here to make sure that the responses are actually good, and then compile those into our training data. So we're going to build a data set from there, do a test, train, split, and then we're going to train a student model with it. So since we've already run the eval, we've already scored all these generated responses, we can just look at the individual responses and their scores, and we could set, I think it's called a high pass filter or something. So we'll say, find anything that was scored above a 6. So take all those high quality responses from our model under test, in this case 03, and collect those together. Technically, the code here is doing it for all models to find the winner. So if you weren't going to just visualize the bar chart and look at the winner and pick it that way, you could also do it programmatically if you wanted to automate this. But that's it. It's, the entire code fits on this one slide. So out pops, in this case, 89 excellent results. Split that in 80, 20, 90, 10. I can't remember what we do for training and validation. But then we run our supervised fine-tuning job. And we can see a nice train loss decrease over time through the different epochs here. So it starts out pretty high around 3 or 4 and kind of ends down sub 1. So it generally indicates that 4.1 nano in this case was learning something from our training set. Once the training job's complete, we deploy it to developer tier. So this is where developer tier comes into play. So this is our non-production tier for hosting fine-tuned models. So it's all about model validation, tire kicking. You got a model candidate, throw it in developer tier. You don't really need the high availability, long life. So in exchange for that, you just pay per token. So if your eval is only a couple tokens just to kick the tires on this thing, this is fractions of a penny. Once the deployment's created, we're really on to the last step, which is validating our model candidate. So did distillation work? So we've already got the evals created. We can just rerun the eval with a new model included, in this case 4.1 nano star. In this case, what we'll actually do is run a smaller eval with just our distilled model, the original 4.1 nano, and then we'll throw in 4.1 as a control. So a quick eval here of the kind of before and after, if you will, the base model of 4.1 nano and then the fine-tuned version. We can see the fine-tuned version comes out way on top, easily surpassing 4.1 and blowing the original 4.1 nano out of the water. And when you look at the score distributions, we get a lot more 6s and 7s and some 8s, whereas with 4.1 nano, we're still getting a tremendous amount of 1s and 2s. And when you bump these up against the original scores from the original baseline, it's performing quite well, on par with the original teacher. Now, this probably isn't going to be the case all times. Distillation, like any sort of data science workflow, garbage in, garbage out. So you always have to validate that you've done a good job producing something of high quality or increase the quality of whatever you were distilling here. In this case, it's pretty straightforward that nano has been improved immensely. So we'd be able to drop in 4.1 nano in place of 03, for instance, and chances are it would be a perfectly valid substitute for this use case. So I'm not saying 4.1 nano now magically behaves like 03. That's completely ridiculous. But for this particular use case with this prompt, it's perfect. We've suddenly got a cheaper, faster, better model to focus on. So now we've got a couple minutes left. Let's take a look at the notebook, and I'll give you some directives on how to get started in taking a look directly at the code. So there we go. So we've got a few steps just in the beginning to get your environment set up. So if you're going to run the notebook, it's designed to be run top to bottom. You can just click run all and walk away and come back in an hour or two, and everything should be done. Training can take some time. But first, what you need to do is create a .env file. If you're not familiar with those, it's just a local text file that's going to include any key value pairs that will be used in the environment for things like the API key or the OpenAI endpoint. I'm not using the Entra ID here, just using the OpenAI key. So this technically is interchangeable with OpenAI directly if you swap the client out. But once you've got those defined, you can run through the initial requirements installation, instantiate the Azure OpenAI client, and off you go. Some of the cool things to call out are really in the initial distillation from the teacher. Here's where we're iterating over all of those distillation results, or evaluation results technically, to create our distilled data. So this is a good example of how to use the evals API directly. So in this case, we're just using the OpenAI evals API within Azure, using the OpenAI SDK, and just looking at all the individual details coming out of each run. So every item that was scored, every prompt that was scored by the evals framework for every model, we can take a look. We can say, okay, let's find our high quality. In this case, I think we do the cutoff at 6.0. I think that's the same thing I had in the slides. Find the high quality results and collect them together. Now, technically here, we're not just assuming O3 is the winner. We're going through for all of the models we tested and making sure we've collected it all together and found who's got the most high scores, if you will. And from this, we build our training data. So if you're new to fine tuning and you're new to this part of Azure OpenAI and the OpenAI SDK, this is some good examples of how to use all these different pieces. So this is using the Files API to, first of all, create the JSON-L data, use the Files API to upload it, and flag it as this is training data for fine tuning. So these are all those kind of building block steps you would need to go about fine tuning a model anyway. It's just part of our distillation workflow. Now there's some helper code in here, if I can get to it, to help visualize. I'll just use a scroll. So pardon the rapid scroll here. To help visualize the results from the evaluations API. So anytime you run an eval, you're going to get one or many runs that that result in a score. You can inspect that data through the API as well. So if you don't want to use the Foundry UI in the web, you can just use programmatic access. There's a helper function here in a piece of Python code to help pull that data down kind of en masse and use NumPy and then matplotlib to build out these little cute bar charts. So that's where all those visuals from the slideshow came from. So everything should be reproducible here. I've run through this quite a few times, and quite often we get the same result of the distilled model being quite good compared to, O3. So in this case, this was the run where it didn't come out exactly the same, but like I said before, it's still definitely is much better than before with 4.1 Nano. So you can see some nice variation where 4.1 Nano before and after just base model, scored somewhere from 5 to 10%, hovering around there, because we're not tuning any of the stuff to make this deterministic. Whereas still the distilled fine-tuned model, it's still up there. It's the best other than the teacher in this case. So hopefully this was entertaining and educational. Definitely take a look at the notebook, and I'm curious what questions people have. Thanks.
Thanks, Dave. That was awesome, and loads of questions. Lots and lots of questions. So we'll fire through these. So the question from JK is, to fine tune or to RAG?
It's a question almost like, should I have another glass of water, or should I take another bite of my sandwich? They're like satisfying two different needs in a way, but they go well together. So fine tuning is going to be great for that situation where extra knowledge, especially external knowledge, won't help improve the model's capabilities to solve the problem. You might want to combine both. There's a concept called RAFT, which combines both retrieval augmentation and fine-tuning. So if you have a situation where you've got a use case that might be highly specialized, some sort of NLP, but benefits from external data, you can combine both into, it's sort of like mixing peanut butter and chocolate into something that's better than just, the constituent parts individually. So it's really kind of not an either or, but I guess if your problem is specific to needing external knowledge, you go with RAG. If it's about changing the behavior of the model to improve how it works with external knowledge, you'd want to go with fine tuning.
And again, it comes back to those questions we said before about cost and the frequency of the change of data. If you're continually changing data, fine tuning is a moment in time. So it's a great answer on that one. Next question from Jose Silva is, what's the difference between fine tuning and RAG when it comes to LLMs? I think we've sort of answered that already, in the previous question, Jose. So I think, just as we said, RAG is where you're adding data to an existing model. Fine tuning is where you're changing the underlying model itself by adding either additional data or removing data from that model. So that's the real key one of fine tuning. Jose Silva's got another question. So what are the constraints about the amount of information RAG systems can handle? Is it just the model context window?
Mm-hmm. So this is a good kind of question that feeds into fine tuning. So yeah, you're typically limited by the context window, which while contexts are getting larger, upwards of like 1 million tokens for some models, that does obviously drive up the cost. And in some cases that can drive up the latency of the processing as well. So you'll often find yourself at the point where, while you can shove, your entire code base for a project into the context window these days and ask a question about it, if you're trying to build like real-time agentic systems that need to respond quickly and confidently, just shoving more stuff into the context is eventually going to have diminishing returns, if not hurt the performance of the model. So that's where something like fine tuning can optimize the model's behavior, so you don't have to put as much in that context. So even if you are doing RAG, you might use less examples, maybe get it down to 1, unless the external content that's being retrieved is specific for answering the user's question or the system's question.
Yep, excellent. So Cheyenne asked a question. So Cheyenne's on LinkedIn. So welcome to everyone on LinkedIn. What skills or concepts are the most important to learn before attempting fine tuning in a real world enterprise project?
Yeah, so the cool thing is I'm not a data scientist. I don't have a data science background. I've been sort of exposed indirectly by working with data scientists. But fine tuning, as we've presented it in things like AI Foundry, should be relatively accessible to folks who don't have formal kind of data science background. The core kind of skills you need are really, you need to be familiar with, prompting and ideally prompt engineering. So you've gotten your hands on, the language models, you've been using them to build, you understand how they work. And then the other part is understanding the problem you're trying to solve. So it could be a classification problem or a tool calling problem. Being able to describe and give examples, you're basically, with certain types of fine tuning, like the kind we used in the demo, which is supervised fine tuning, you need to show the model what you want it to do, given an input and an output. So if you're not able to express that yourself, the model's going to have a hard time learning from you. So kind of the skills you would need are really being able to be very focused and kind of concrete in how you explain the problem, or maybe to somebody else. It's like if you can't explain it to another human being, you can't write it down and kind of put together a plan for like, these are the types of inputs I would want, and this is what I want as an output, you're not going to be able to train the model very well. So it's sort of like the more you get better at communication, I would say, it's kind of like a, maybe a softer skill, the better you'll be. Picking up some of the more harder skills on the data science side around like, how big is my training set? What should I do with hyperparameters? That stuff, we've designed AI Foundry to kind of hopefully give you the happy path, but then you can start tweaking and tuning and learning as you go.
Yeah, it's a great answer. I think, just to stress, with it, Azure AI Foundry, the key thing is that one button, like fine tuning and distillation process. So it literally is like one button. And going back to what Dave said, the key requirements are really building what we call the JSON-L file, which is your pairs of answers and questions. So again, if you can ask the question really well, you can use synthetic data. So there's services like Retrieval AI and some synthetic data in Azure Foundry to create those JSON-L training files for you. But if you ask the wrong question, your training file is going to be terrible. So it's the garbage in, garbage out. So again, you can actually just try that and see the difference in the results. And what was great in Dave's demo, if you want to watch it back, is he shows the benchmarking. So what we call the evaluation of the model, and that's where the model is graded from 0 to 5 on the groundedness, relevance, coherence of the model output. So it's really key to look at that evaluation piece. Next question we've got is from Gravels. He said, prompt engineering on foundational models, is it considered fine-tuning?
Not technically.
That was my answer as well.
Yeah. I mean, kind of like, yeah, the answer you gave earlier, Lee, is, fine tuning is about changing the model, not changing kind of the prompt. So it's that's sort of how to look at it, is you're fine tuning the, what you're actually producing behind the scenes are new weights that work with the model when you're fine tuning. Whereas with prompt engineering, you're just kind of influencing, the probabilities of what's going to dictate the output on the other side.
Excellent. We'll do one more question. It's from Cheyenne. He's basically asking the question on overfitting. So, when you're using data sets, what are the good practices to avoid overfitting of data?
Yeah, and if it's especially challenging in a particular domain, synthetic data is probably one of the better ways to go to increase the size of your training set and to make sure you have enough for validation as well. That's where using an LLM to help generate the data, using something like evaluations to, confirm the quality of that generated data, is probably going to give you a better foundation to prevent overfitting, other than doing hyperparameter tuning and things that require getting more, data sciencey, if you will. There's some customers I work with that will do a lot of different hyperparameter tuning and run different training jobs with different knobs set different ways, but kind of getting that foundation of the right training data put together is really key.
Yeah, definitely. So, huge thank you for Dave coming along today. We will be with Dave on Friday in the Azure AI Foundry Discord channel. So please join us for an AMA. We're going to have more time for just pure questions. So there is a few questions we've not answered. So please do bring them on Friday. Please come into the forum and ask the additional questions. But huge thank you for the time today, Dave. And that was a great overview.
Thanks for having me, Lee.
Great. So one of the new things that we're going to be introducing in the coming week, so this is not like going to happen now. This is something we're thinking about. It's going to be customer stories. So we're going to be bringing along customers to Model Mondays for them to share their experiences of how they're using models within their enterprises, within their business, within their agents. So this is something we're going to be launching over the next few months. Again, we really want to showcase how people are using these models and the types of models. And again, for you to hear firsthand how people are putting these into their enterprise scenarios. So next week, we have research and innovation. So it's going to be hosted by Kim Fei. And we've got the researchers from Core AI, so Sharon and Xinging, and they're going to be talking about the new foundational and research models that we're going to be launching in Microsoft. So part of what we call Foundry Labs. So there's going to be some really exciting things being showed next week from the research and innovation perspective. So please join Kim Fei for that session. Again, we will have an AMA with that team on the Friday after. So as I said, Dave will be with us on Foundry Fridays. It's purely an AMA session. It's going to be time of 30 minutes, purely question and answers. So please do bring along your questions. We've given you all the resources for today and for the demos that Dave went through. So please have a play with them. Please bring back your feedback, any questions that you do have. And do join us in the Azure AI Foundry Discord, and the GitHub forum. We want your questions. We want to hear from you as a community, what you're doing, how you're using these tools and technologies. And again, we really want to learn from you and for you to learn from us. So our key call to actions for you is, watch Mondays. This is what this session is. If you can't watch it on Mondays, please watch it on demand. It is available on demand on YouTube. Please join the AMA and ask your questions and get real in-depth answers from the experts and the product teams and the people who are actually building, designing and implementing these solutions. And of course, you can find the recaps of these forums, the transcripts, the questions and answers that were asked, and access to the slide decks with more information and resources, all within the GitHub discussion forum. So a huge thank you for joining us today. We hope you've enjoyed the format of today's session, and we really look forward to seeing you all soon. So huge thank you.